I'm gonna talk about 11.5 lines and planes in space. Consider there's a line L passing through the point P, x1, y1, z1, and is parallel to the vector v equals to a, b, c. The vector v is the direction vector for the line L, and a, b, c are direction numbers. Here are the equations for parametric equations. X equals to x1 plus at, y equals to y1 plus bt, z equals to z1 plus ct. The symmetric equations equals to x minus x1 over a equals to y minus y1 over b equals to z minus z1 over c. So the first example is to find the parametric and symmetric equations of the line L that passes through the point 1, negative 2, 4, and is parallel to v equals to 2, 4, negative 4. So we first let x1 equals to 1, y1 equals to 2, and z1 equals to 4. And then we let a equals to 2, b equals to 4, and c equals to negative 4. And then according to the equations in the above that we already talked about, the result we get for parametric equations are x equals to 1 plus 2t, y equals to negative 2 plus 4t, z equals to 4 minus negative 4 minus 4t. And the symmetric equations are x minus 1 over 2 equals to y plus 2 over 4 equals to z minus 4 over negative 4. Here is the standard equation of a plane in space. Is a times x minus x1 plus b times y minus y1 plus c times z minus z1 equals to 0. For example 2, we need to find the general equation of the plane containing the points 2, 1, 1, 0, 4, 1, and negative 2, 1, 4. We first let the second point minus the first point, and we get u equals to negative 2, 3, 0. And then we let the third point minus the second point, and we get negative 4, 0, 3 for v. And then to find the normal vector, we need to do the cross product of u and v. And then we get the 9i plus 6j plus 12k equals to abc, which is the direction vector. We then plug in the direction vectors into the general equation. We get 3x plus 2y plus 4z minus 12 equals to 0. Here is another equation that we need to use when we need to find the angle between two planes. Example 3. We need to find the angle between the two planes given by x minus 2y plus z equals to 0, and then x2y plus 3y minus 2z equals to 0. We need to let n1 equals to the first equation and n2 equals to the second equation. We then plug n1 and n2 into the above equation, and we get the number is roughly equals to 0.59409. When we need to find the distance between a plane and a point Q, the formula is this. For the fourth example, we need to find the distance between the point Q, 1, 5, negative 4, and the plane given by 3x minus y plus 2z equals to 6. We first let y equals to 0 and z equals to 0 and plug them into the equation, and we get the point P, which is 2, 0, 0. And then we use the point Q, which we already have, to minus point P. We get the vector PQ, which is equals to negative 1, 5, negative 4.
And then we plug PQ into the equation we already have above, and we get 16 over the square root of 14.